My name's Tim Brandwood and I'm CTO and one of the co-founders of Digital Taxonomy. Today we're going to talk about how AI allows us to listen to customers in a more automated and cost-effective way. We've worked with many clients over the last few years and learned a lot about how best to use AI to make sense of open-ended feedback given to us by respondents. We've experimented with various techniques, and without giving too much away at the start, we've learnt that in the end the best results come from blending techniques together rather than looking for a single silver bullet. So in this webinar I'd like to bring some of that together and share some of the things we've learnt along the way. To set the scene, at Digital Taxonomy we currently have two automation products in our portfolio. Loadit, shown on the right there, is our data automation tool that allows mere mortals to easily automate repetitive data processing tasks. I'm not going to go into detail on that today. Instead, I'm going to talk about our coding tool, Codit, there on the left. Codit, for those of you who don't know, is a tool that helps automate the coding of open-ended survey responses. And as I'll show later, it blends a variety of AI techniques to improve productivity, speed and quality. The traditional approach to dealing with text data from surveys should be fairly familiar to all of us on this webinar. You ask someone an open question, and in order to extract the rich content from the responses, you pay somebody to read each comment and choose from a code frame all of the categories that apply. Once you've applied codes to all the responses, you can then analyze the results, effectively turning a set of rich qualitative responses into analyzable quantitative data. This is how it's been done for many years, and it's a slow, expensive and often error-prone process. Over time, the cost and hassle of dealing with this kind of data has led researchers to use open-ended questions less and less. Obviously this is a shame, as open-ended questions represent a unique way for customers to express themselves and tell you what they think. So with the current advancements in AI, there must be a way to speed this up. There must be a way to get the computers to do all of this for us instead. It would be great, wouldn't it, if we could just throw all of our customer comments at one of our robot friends here, and he could automatically spit out an insightful summary of what the data is telling us. Unfortunately, spoiler alert, there's no silver bullet that can magically do this for us at the press of a button. There are, however, text analytics tools, including our own, that can get you part of the way there at the press of a button. They can extract phrases from the text and will often generate a sentiment score along the way. But this will give you a fairly crude read of the data on its own and only a general sense of what it's saying. That's rarely enough for marketeers and researchers. In the real world, the challenge of coding is to capture not just the broad topic, but also the nuance. It needs to be sensitive to the detail, whilst also providing a concise, usable summary of the data. So here, for example, there's no meaningful difference between big screen and bigger screen, but there is an important subtle difference between, say, atmosphere and immersive. Just to make things even harder, all of this is set against a backdrop of interrelated factors that together determine the complexity of the coding task. So, for example, how long is the text you're trying to code? How much time have you got? What's your budget? How clean is the data? How much historical data do you have? How granular do you want your final analysis to be? All of these factors affect what techniques are appropriate and how effective these techniques will be in providing meaningful data. So the aim of the rest of this webinar is to look at a few of these factors and show you how our approach might vary in response. So firstly, let's think about a case where you have historical data available. If you do have a reasonable amount of good quality historical data, then this can be used to great effect to train the Codit machine learning. So here we see a set of previously coded data being fed into our robot friend to train the Codit AI. And once trained, when the AI is given a set of new uncoded comments, it can reapply this learning and automatically code these new items. And this is clearly a great use of the machine learning approach. Using this approach, the outcomes tend to divide into three categories. There are verbatims which the AI is certain how to code, so it just automatically codes them. As many as 60% of the comments can fall into this category. There are also items where the AI is less certain, but can still guide the coder to speed up the process. I'll show a screenshot of that in a second, but typically 15 to 30% of items will fall into this category. And lastly, there'll be a certain proportion of items that the AI just cannot code. These might be new themes, new expressions of existing themes, ambiguous statements, badly written statements, and so on. And in our experience, these items are best handled by a human coder, and it's actually more efficient if the AI just gets out of the way and does not interfere with the process. Here is an example of that second category of items. Here we see the AI providing suggestions to the coder to help them work through items quickly and efficiently. And of course, as I mentioned earlier, there'll always be certain items that the AI can't make sense of. So here are some examples where the respondent is using phrases that don't exist in the training data, or the text is mangled and our robot friend can't be sure of what's being said here. In these cases, it is important to have a human coder on hand to help out. So as an example of all of that in action, here are some results from one of our clients. In this case, we're focusing on the NEC, who manage a number of exhibition centres and venues in the UK. They collect feedback from customers about their visit to one of their venues, and we have about 2 years worth of historical coded data, which is used to train the artificial intelligence. When new customer comments are fed into the system, over half of them are automatically coded by the system. Around 10% of items fall into the assisted coding bucket, and as you can see, around about 37% remain uncoded by the AI, which can easily be reviewed and handled by a human coder. The net effect is that the coding process requires about 3 times less manual effort, and the customer feedback loop is much shorter. So, taking another variable into consideration, the length of the text being coded is a very important factor. As a simple example, here we see some brand names that need to be coded, and in this case it's simple. We can just produce a distinct count of the responses as they stand. Simple text matching like this is cheating really, and it's not really real AI, but it is surprisingly common as a requirement and is extremely efficient when it can be applied. Slightly more realistic is this example, where the data contains all manner of misspellings. As it turns out, machine learning is not the best tool for the job here. Machine learning tends to work by utilising pre-trained dictionaries of known words. So, training machine learning on the phrase McDonald's correctly spelt is fine, but it doesn't really help it to magically know how to handle the misspellings. Typically, you would tend to find a large number of different misspellings when coding shorter responses, which will build up to form a long tail and collectively ends up being a big part of the job. So to tackle this problem, we've developed a system that allows the coder to provide the AI with pattern matching rules. It takes a bit of thought and craft, but the effort's worth it. In this example, we've created a simple rule that will correctly match all of these various misspellings of McDonald's. But here's a word of caution. Text matching rules are great, but you need checks and balances in place. It's important to make sure that you're not overmatching. So in this example, we're trying to match the keyword new to denote newness, but we also need to add exceptions to the rule to exclude things like New York, New Delhi, and so on. So as an example of that in action in the Codeit UI, we have a code frame here on the left with our new code in there, and it's very easy for the coder to add new as a keyword to match, but also add an exception to exclude the overmatching against New York, New Zealand, and so on. Lastly, what happens if you don't have any prior training data and you have much longer verbatims than the simple brand coding we just looked at? Well, as I mentioned earlier, one approach is to use text analytics as an initial pre-processing step. So in this example, the text analytics is actually very good at extracting the themes from each comment, but inevitably it leads to a very unrefined output. So on its own, it's not good enough for our purposes. However, I think we've made it very easy for people to provide a bit of human intelligence and refine this into a more appropriate and useful code frame. As an example of that in action, we see here the Codeit user interface, which is showing a set of segments that have been extracted by the text analytics from a set of verbatims, and it's built a crude rough code frame there on the left. So it's very easy for a coder to come in and refine the code frame and turn it into something that is far more usable for market research purposes. Bringing all of these techniques together, you can see that our approach is really a system of layers that can be applied as appropriate depending on requirements. So when a verbatim comment is presented to the system, we might apply text matching, i.e., is this verbatim exactly the same as one that's gone before? We might apply some predefined rules to code the data, as we saw with the McDonald's example earlier. We may use text analytics to extract segments of text and derive codes from that. We may allow the AI to apply codes based on the machine learning derived from prior examples. But crucially, if all else fails, and at some point it probably will, people should act as a backstop, as a fallback. Personally, I think this is as it should be. The computers automatically take care of the easier, repetitive stuff, leaving real people to focus on the exceptions, the new themes, and the interesting, unique stuff. There are a couple of interesting feedback loops in there too. When items are manually coded by a person, this provides additional training data for the machine learning to learn from, which will improve it continually over time. Also, it's possible for the machine learning to train using examples coded by the text analytics, which is quite a surprising idea when you think that it means that one machine system is basically training another one. I'll come back to this concept in a few minutes. To illustrate all of that in action, here are some details relating to a project we undertook with BVA BDRC recently. They had about 50,000 hotel comments that needed coding against tight time and budget constraints. This seemed like a perfect example to show off our blended approach. So now I'm going to walk you through the various stages in this project. This is a relatively heavy chart, so I'm going to walk you through it step by step. The first step in this process involved deriving a code frame from a set of key themes extracted by the text analytics. This resulted in a code frame containing about 39 items. And so the first bit of coding was done by automatically matching any verbatims against the text in those code frame items. And about 1,500 items matched in this way. So the verbatim text exactly matched the text in a code frame. We then used the text analytics to further create a set of around 700 keyword matching rules. When these were applied, the result was a further 25,000 or so items automatically coded. These coded items then act as a large training set for the machine learning to learn from. After training the machine learning, it was able to automatically code a further 17,000 items. After that, about 2,000 or so were coded by a couple of human coders, and then we reran the machine learning again, resulting in about 1,200 items being coded. At this point, we felt that the machine learning had probably plateaued in this case, and so we left the remaining 4,000 items to be checked and coded by hand. The net result is that out of the 50,000 original items, roughly 44,000 were completely coded automatically, and only about 6,000 items needed to be coded by hand, which means that a task that would have taken weeks to complete only took a few days, which is a huge time saving. Furthermore, I think this is an excellent illustration of the need for AI and people to work together, rather than thinking of AI as necessarily replacing human workers. So where do we see all of this going in the near future? Well, one idea is summed up by the joke here: life begins at 1 billion examples. It's certainly true that the more training data you give to the machine learning, the better it will perform. But currently, market research tends to be divided into quite small silos, so the amount of data available to the AI is more limited. So one approach we've been working on to this issue is to structure the architecture of our software to make it easy to pull data within a company or across companies or even across whole sectors. It's an ambitious goal which will require a bit of a coordinated effort, but the benefits to the industry could be huge. As an industry, over the last few decades, we've probably collected billions of open-ended responses on every conceivable subject. Wouldn't it be great if we could just tap into the value of that resource by pooling the data and building smart AI-driven tools with it? Verbatim responses are a unique form of data, a direct answer to a direct question, which, if harnessed as a big data resource, could become a unique source of insight and value for our industry. We'll probably return to this theme in a bit more detail in a future webinar. So to summarise, remember that there's no silver bullet in all of this. The real world is more complicated than that. Instead, it is necessary to use a blend of techniques to achieve the best results. And of course, people are an essential part of that mix. As we've seen, human intervention of various sorts is what makes the difference between a mechanical low-value output and the high-quality outputs that we expect in research. And finally, we must bear in mind that this kind of AI technology has only come into the mainstream in the last 5 years or so. So over the coming years, there will be further techniques and innovations that we can use to help us decode what customers tell us. So with that, I'd like to say thank you to everyone for joining us today. And as we have a few minutes left, I'd be happy to answer a few questions if anyone has any.
Hi everyone, it's Pat Malloy here. I'm going to look after this little Q&A session now. If any of you do have questions, a few have come in, but if any of you do have questions, you need to move your mouse towards the bottom of the screen, and there's a little Q&A box down there, and we'd be happy to take any questions and answer them as we go now. But perhaps I'll just start off with one or two that have come in already. And the first one is, Tim, can I use other survey variables to help the human coders make sense of any open-ended answers that they're coding in CodeIt?
Yeah, that's a good question. We didn't cover that in the webinar explicitly, but often when you're coding, it's important to be able to see other variables from the questionnaire sort of alongside the verbatim responses. I mean, more often than not, an open question is used as a follow-up to another question, so it can be very useful to be able to see what the previous answer was in order to make, to provide context to the verbatim. So yeah, when you load data into CodeIt, there's lots of options for sort of bringing in additional variables and then displaying those sort of alongside the verbatims while you're coding.
Thanks very much. I hope that answers the question. If not, just come back onto the Q&A panel and we'll deal with it further. Another question that I see here, which one that we've heard a few times: what languages can CodeIt actually support?
Yeah, that's a very good question, and again, that's another example of a real-world complexity that makes all of this stuff, more challenging. Often, big surveys tend to collect data in lots of different languages, so there are actually various different ways that people like to tackle that. So one method is to simply load the data in the native language and display that to a native speaker and have them code in that native language, and so that's that allows a slightly faster turnaround, because obviously there's no need for any sort of translation, and so you just code the data raw. So CodeIt fully supports that, and we can display the code frame either in that native language as well, or we can display a sort of translated version of that code frame. Sometimes people like to code in the native language, so keep the verbatims in the native language, but actually just have a single English code frame, for example. So there's lots of permutations here, so that's one of them. Another option is to translate the data outside of CodeIt and load it in as translated data. And obviously that's doable, but that's slower because you're doing the translation manually. So to sort of help with that, we've built a mechanism into CodeIt that will auto-translate verbatims from the native language into, let's say, a common based language like English, and obviously we're using some machine translation for that, so the APIs that are just out there, and for most coding purposes that actually works really well, because although those translation services are not perfect, they do capture enough of the meaning of what's being said in order to sort of enable coding to happen. So there's sort of various different ways in which we support multi-language coding in Codit.
Great, thanks, Tim. Next question, let me just see here. Suppose I just want to integrate Codit into an existing system, for example, our pre-existing data collection system. Can that be done somehow?
Yeah, that's a fairly common requirement that we get. Often people have existing systems or they have their own in-house, say, data collection systems, and they just want to be able to sort of plug into the services that Codit offers. We have a really quite extensive API sort of behind Codit. So if you have a sort of technical resource that can work with a REST API, then we have the ability to sort of configure Codit to put data in, pull data out, you know, all the various sort of data flows that you might need to implement. And in addition to that, we expose all of the machine learning and all of the AI components as endpoints on that API. So if you wanted, for example, just to send data in and get a response back or coded response back, you could do that and just use the API just for that specific purpose. That's getting a lot of interest from people who are wanting to sort of code on the fly. So take an open-ended response from a respondent, categorize it on the fly, and then maybe route the questionnaire or adapt what the respondent is asked based on what we know they're saying in that free text. So that's quite an interesting technique, which I think is gaining quite a bit of interest. I think maybe that could make quite a good subject for a follow-up webinar, because I think that's quite an interesting thing to see in action. So maybe we could do a little demo of that next time.
Great, thanks, Tim. Just a couple more questions here that I can see, or maybe three. Can Codit use the text analysis that you showed to automatically generate the initial code frame?
Yeah, certainly can. In fact, that's what first got us interested in the text analytics in the first place, because the process of generating the code frame is often quite a time-consuming process. So anything that we can do to assist coders and sort of jumpstart that process is really, really useful. So what we found is that, as I said earlier, the text analytics gives you sort of a fairly crude extract from the data, which actually is a really, really useful starting point for a sort of draft code frame. Again, as I mentioned earlier, you wouldn't use that just without sort of tweaking it. But as a starting point, that actually gets a coder quite a long way down the road before they need to sort of intervene and sort of tidy up a bit. So again, it's this sort of interplay between people and machines sort of working together and getting the job done faster.
Great, thanks, Tim. Two more questions, actually. One more has just come in. Here's a good question. How much of a saving on human coding time do customers get on average?
Okay, yeah, the saving can be sort of anywhere between sort of 50%, so coding takes half as much human time, or right up to 90%. So as we saw in the two case studies I mentioned a few minutes ago, the way the NEC use the machine learning means that they probably have to put about half as much effort into human coding as they did before. But the fully blended approach that we demonstrated with BVA BDRC just there, that's taking something that would take 30 days and doing it in 3. So that's like a 90% time saving. So that's absolutely massive.
Fantastic, thanks, Tim. And just the final one, it's quite a long one. Let me see if I can read this properly. Can the machine learning identify verbatims where the human decision is most needed to allow the algorithm to learn effectively, then feed those verbatim comments to coders? So it's sort of prioritizing verbatims, hard verbatims, I guess, or something like that.
Yeah, that's a good question. Obviously, the machine learning will struggle to a greater extent, the longer the verbatim is. So just on a sheer probability basis, a short verbatim where somebody is talking about one thing, it's much more likely that the machine learning will get that 100% spot on than a very, very long verbatim where the respondent's talking about 10 different things. In crude terms, the longer the verbatim, or the more the more mangled the verbatim, or the more unique the verbatim, the less likely it is that the machine learning will get that spot on first time. So to sort of help us with that, the machine learning will output a sort of confidence score for every suggestion that it makes, and that confidence score tells us how confident the machine learning is that it's got it spot on. So obviously something that is 80, 90, 100% confident will just auto code that. That's great. And so that's sort of what drives that, the auto coding and the guided coding and the sort of manual coding that those three sort of buckets that we saw earlier. But it can also be a really useful technique to prioritize the items with the lowest confidence score, because they're obviously the ones that the machine learning is most lacking on and needs more sort of input data and training data to help improve. So as it happens in the case study there with BVA, the 2,000 items that were done by hand were manually sort of selected as the items that the machine learning was the least certain about. And so to some extent, although we haven't exactly quantified this, but to some extent, there's a good chance that the increased auto coding that the machine learning was able to do after that is as a direct result of the kind of new information we've given it by coding the kind of the least certain verbatim. So that's definitely a really useful technique.
Great stuff, Tim. Thanks. And in fact, I lied. There's one more question that's just come in. And here we go. If you have different types of surveys, can you save different models that best match the opens for each survey category?
Yeah, that's a good question. We allow for the machine learning in Codeit to be sort of recycled, if you like, across different projects. So learning that it's gained in one setting can then be reapplied in another one. Now, there's been some research that suggests that the category is less important than you think it might be. So, for example, if people are telling you that they really love the service, it doesn't necessarily matter whether they're talking about their bank or a local restaurant or whatever. As I say, there's been some research that sort of indicates that. So, to some extent, you could take the learning from the machine learning from one survey and apply it to another, and then ignore the context altogether, and you still get some quite good results. But beyond that, one of the things that we are working on is a sort of more fine-grained mechanism of being able to sort of share learning across projects. So, for example, you might share a code for good service because that's a sort of universal attribute that people might talk about. But you wouldn't necessarily take a code, about overdraft fees or interest rates and then bring that into, share that into your restaurant survey. So one of the things we're working on is the ability to sort of pick and choose and have really fine-grained control of that sort of sharing. And again, maybe that's something we'll return back to with a webinar in due course and sort of show that in action, because I think that gives you the ultimate sort of flexibility to cope with different contexts and different surveys, and sort of reusing that learning to best effect.
Okay, I'm just wondering if that's the answer to a slightly different question. Let me just try and see if I've interpreted the question. I would perhaps rephrase it slightly different. It seems to me that you might have surveys about, restaurants and surveys about banks. Presumably safe. I think the question is saying, can I share my restaurant learning amongst my restaurants and keep separate my bank stuff amongst banks?
Oh, so the other way around. So okay, yeah. So we allow the ability to completely control what gets shared with what. So if you want to keep your machine learning in your code frame for project A, completely isolated to project A, then that's totally fine. That's the default position. But it's you as the user that gets to pick and choose where that learning gets reused. So that's very much a sort of an opted-in process by the user, as opposed to some automatic sharing that just happens, because that's not what we're after at this stage.
Okay, I hope that's answered the question properly. If not, you'll come back to us and ask us. We're obviously happy to answer any other follow-up questions that any of you might have. But I think that brings us to the end. I'd like to thank all of you very much indeed for coming along to hear us talk about our favourite subject. Look out for more webinars. As Tim mentioned, we'll be focusing in on a few of these techniques, and just wishing you all a nice rest of the afternoon. Thanks very much for joining, and goodbye.